and 70% wins nothing. Okay? Let's try to do the chi-square test of goodness. Of course, I could make more categories and make it more realistic, but I just want to show you a quick run through with a simple example. Right? So, let's say Jack bought 200 lottery tickets. One because he was rich, and second for science. Okay, and then found 12 $5 tickets, okay. And then also found 31 $2 tickets, and rest winning nothing. Is the lottery ticket sellers claim true? In other words, with this data, can you show that the lottery company's claim is false? Okay? So, let's try this. So, for the hypothesis testing, the H0 is that proportions are indeed 10%, 20%, and 70%. That's your null hypothesis. Alternative hypothesis is it's different. Okay, so that's step one. You have to state the null hypothesis and alternative. Step two, you have to show, you have to decide the rejection region. Since we're doing chi-square goodness of fit test, we need to first determine the degrees of freedom. What's the degrees of freedom here? 2, because there are 3 categories. You subtract 1, and degrees of freedom is 2. The degrees of freedom actually makes sense. The word degrees of freedom makes sense because if this was increased to 30%, what's going to happen? The other has to decrease, right? So degrees of freedom basically means that if you know 2 of them, the third one is automatically determined. What is the actual degrees of freedom in this case? It's just 2. That's how you think about it. Okay? So that's degrees of freedom. And then for the chi-square degrees of freedom 2, we have a table here. The rejection region is 5.991 if we say the significance level is 0.05. So with significance level 0.05, so again, that's the chi-square distribution for 2, and then here is 5.99. I'll just use 5.99. So that's your critical value. So we've determined the rejection region. Okay, now let's try to do the chi-square test statistic. So step 3, you have to find the test statistic. And it's the sum of observed minus expected squared divided by the expected. So observed is 12. What was expected? What's 10% of 200? 20. Squared divided by? 20. plus. Observed was 31. What was expected? What's 20% of 200? 440. Right? Squared and you divide it by 40. Okay. Plus, how many didn't win? 43, so 157? Yeah, right. So 157 was observed, and you're supposed to be getting 140. And you're dividing it by 140. Okay? Can somebody do this for me with a calculator? I'll just do it. So we have 12 minus 20 squared divided by 20 plus 31. Have you got it? 7.2. Okay, let me just verify that by here. 157 minus 140 squared divided by 140. 7.29. Good, thank you. So you have this value as 7.29. And what's our conclusion? It's in the rejection region. So number 4, we reject H0. And now Jack can bring all this and sue the lottery company. Take it to the court, say, here's my analysis. They've been ripping us off, right? So that's how this goodness of fit works. Now notice that this just says that overall the proportion is not the same as this. It doesn't tell you which one should be higher or lower, but we kind of know from the data, right? The conclusion just says that it's not, the outcome is not according to the proportion, so the original claimed proportion must be wrong. That means some of the values should be either increased or lowered. From this one, we kind of see that this should be increased and these others should be decreased. But that really doesn't, that's a conclusion that's not from the chi-square goodness of fit. It just, goodness of fit just says it doesn't fit. That's our conclusion if you reject the null, right? Okay. I'm going to be, so we don't have